Hey YouTubers, thanks for joining me here at Random Chemistry. In this video, we're going to continue to practice mass-to-mass conversions. And here's our balanced equation. 2Mg reacts with O2 to produce 2MgO. And it's asking us to calculate the mass of O2 needed to produce 23.7 grams of MgO. So the first thing that we need to do is to find our molar mass. And we need to find the molar mass of O2 and MgO. So the molar mass of O2 is 32 grams per mole. And the molar mass of MgO is 40.3 grams per mole. And if you're not familiar on how to find molar mass, you can see some of my videos for some practice and instruction. Now that we have our molar masses, we need to find our molar ratio. And we can do that by looking at the coefficients in our balanced equation. We need O2 and MgO. So it's a ratio of 1 to 2. So 1 mole of O2 for every 2 moles of MgO. Alright, now that we have everything that we need, we can solve this equation using dimensional analysis. We're going to start with what we're given. 23.7 grams of MgO. So I need to go from grams of MgO to moles of MgO, and I do that by using the molar mass. So if I have grams of MgO on bottom, I need grams of MgO. If I have it on top, I need it on bottom. So 40.3 grams per 1 mole of MgO. So now grams cancel out. So now I'm left with moles of MgO. So I need to convert from moles of MgO to moles of O2. And I do that using my molar ratio. So if I have moles of MgO on top, I need it on bottom. So 2 moles of MgO for every 1 mole of O2. So moles of MgO cancel, and I'm left with moles of O2. Now I need to convert from moles of O2 to grams of O2, and I do that using my molar mass. 32 grams for every 1 mole. Mole on top on this side, I need mole on bottom. So 1 mole of O2 for every 32 grams of O2. So now moles of O2 cancel, and I'm left with grams of O2, which is what the question is asking me. So now I plug this into my calculator very carefully. 23.7 times 1 divided by 40.3 times 1 divided by 2 times 32. And when I plug that into my calculator, I get 9.40 grams of O2. Here's our second question. Calculate how much MgO will be produced if 74.6 grams of Mg react. So the first step is to get our molar masses. So the molar mass of MgO is 40.3 grams per mole. And the molar mass of Mg is 24.3 grams per mole. The next step is to find our molar ratio. We need the molar ratio of MgO to Mg. MgO to Mg is 2 to 2. So 2 moles of Mg for every 2 moles of MgO. And now we can use dimensional analysis to solve this equation. 74.6 grams of Mg So I need to go from grams of Mg to moles of Mg, and I do that using my molar mass. So if I have grams on top, I move to grams on bottom. So 24.3 grams of Mg for every 1 mole of Mg. Now I need to go from moles of Mg to moles of MgO. And I do that with my molar ratio. So if I have moles of Mg on top, I need moles of Mg on bottom. And my molar ratio is 2 moles of Mg for every 2 moles of MgO. So now moles of Mg cancel, and I'm left with moles of MgO. So I need to convert from moles of MgO to grams of MgO. And I do that with my molar mass of MgO. So if I have moles on top, I want moles on bottom. So 40.3 grams of MgO per 1 mole of MgO. So moles of MgO cancel, and I'm left with grams of MgO, which is what it's asking me for. Now I plug this into my calculator. 74 times 1 divided by 24.3 times 2 divided by 2 times 40.3 divided by 1. When you plug that into your calculator, you should get 123.72 grams of MgO. Alright, YouTubers, thank you so much for joining me during this video with random chemistry. Please comment, like, subscribe. I really want to hear from you. If there's any material that you specifically want me to cover, if you have any questions, please leave me a comment. Thank you again for joining me, and we'll see you next time on Random Chemistry.